Welcome to AMAC KSSM channel. This is KSSM at Max Form 5 exercise discussion. I'm Madam Wong here. Formative Exercise 8.4. Number 1. A cricket player hits a ball and it travels along a straight path through a center P with a velocity of 44 meters per second. The acceleration in meter per second square at t seconds after passing through the center P is given by A equals to 12 minus 60. Calculate A, the maximum velocity in meter per second of the ball. So, when we want to get maximum velocity and we are given the function of A equals to 12 minus 60, first, we need to get the velocity function. So, we integral 12 minus 60 with respect to t, and we get V equals to 12t minus 3t squared plus c. Second, when t equals to 0, the velocity is 44 meters per second. Therefore, c equals to 44. So, the complete function of v is v equals to 12t minus 3t squared plus 44. Then, when we want the maximum velocity happens when the dv dt equals to 0, or the acceleration equals to 0, and we get t equals to 2. So means that at t equals to 2, we will get our maximum velocity. So to get the velocity, we need to substitute the t equals to 2 into the function v. This is the function. So maximum v is 12 times 2 minus 3 times of 2 squared plus 44. Therefore, we get maximum velocity equals to 56 meters per second. B, the distance in meter of the ball from the center P when t equals to 2. So, we want the distance of the ball from center P. So, basically the displacement. Alright. So, look for the function s by integrating the integrating the function v with respect to t. And we get s equals to 6t squared minus t cubed plus 44t plus c. And when t equals to 0, s equals to 0, therefore the c equals to 0. So our complete s function will be 6t squared minus t cubed plus 44t. So now, when t equals to 2, the s will be 6 times of 2 squared minus 2 cubed plus 44 times 2. There we get 104 meters. So the distance of the ball from the center P when t equals to 2 is 104 meters. Next, question number 2. An object moves along a straight line from a fixed point x. Its acceleration a meter per second square at t seconds after passing through a point x is given by a equals to 16 minus 40 for t from 0 to 3. Given that the velocity of the object at the time t equals to 3 is 38 meters per second, calculate A, the initial velocity of the object. So we are given the function of acceleration. We need to get velocity. So we integrate the 16 minus 40 with respect to t. We get v equals to 16t minus 2t squared plus c. We have only the velocity when t equals to 3. So, sub in, when t equals to 3, v equals to 38. Therefore, 38 will equals to 16 times 3 minus 2 times of 3 squared plus c. So, from here, we get c equals to 8. So, the complete equation of the complete function of v is v equals to 16t minus 2t squared plus 8. So, we want the initial velocity. When t equals to 0, v equals to 16 times 0 minus 2 times of 0 squared plus 8. So the initial velocity is 8 meters per second. B, the velocity in meter per second of the object at the 4th second. So when t equals to 4, the velocity equals to 16 times of 4 minus 2 times of 4 squared plus 8. We get 40 meters per second. Question number 3. Objects A and B are placed on a horizontal straight line. A toy car moves along straight line. The velocity in meter per second of the toy car t seconds after passes through the points A is given by v equals to 2t minus 4. At the beginning of the movement, the toy car moves towards object B. Assume motion to the right of the toy car is positive. A. Calculate the range of values of t in seconds when the toy car moves toward object B. So, B, we need to know where is object B. Alright, so basically we need to know when t equals to 0, how is the v, right? So when v equals to 0, we notice that v equals to -4. So the movement of the toy car from t equals to 0 is to the left. So we know the object B is actually to the left of the toy car. So A, we need to calculate the range of t when the toy car moves toward the object B, means that we need to get the time range when the v less than 0, when it moving toward the left. So from 2t minus 4 less than 0, so we find that t less than 2. To be accurate, we can also write t is between 0 and 2 seconds. B, given that the distance between object A and B is 5 meters, determine whether the toy car can reach object B or not. So we know that A is from the point, right? And then B. The toy car is here, okay, and is moving toward B, and the distance between A and B is 5 meters. So we try to look for the function of displacement. By integrating the v, we get s equals to t squared minus 4t plus c. When t equals to 0, s equals to 0. Therefore, the c equals to 0. Our function of displacement is now t squared minus 4t. So, we know that the toy car moving toward B is from 0 to the t second. So, t equals to 2 seconds, right? So, assume that, okay, we try to find the displacement of the car when t equals to 2. Okay. So the displacement will be 2 squared minus 4 times of 2, where we get -4 meters. Means that our toy car only moves 4 meters away, and t equals to 2. Alright, so is it reaching object B? No, okay. So the toy car can't reach object B. Okay. C. Find the total distance in meter of the toy car in the first 6 seconds. So if we ask to find the total distance, and we know that the car from 0 to 2 seconds moved to the left, and it stopped when t equals to 2. Right? When v equals to 0, we get t equals to 2. He stopped when t equals to 2, and he will turn direction towards the right. Therefore, we know by integrating the function of v, okay, we will get the distance. And from 0 to 2, the integration of v will get a negative values since it's moving toward the left. Therefore, we times a negative for it. Plus the integral of v again, but from the interval 2 to 6. Therefore, we get the total distance by this, and sub in all the value, we get 20 meters. D. Draw the displacement time graph of the toy car from object A for the time interval from 0 to 6. Alright, so the displacement function s equals to t squared minus 4t, and we do a little analyze from this function. We have a smiley face because of positive t squared, and when the s equals to 0, we get t equals to 0 and t equals to 4. Therefore, we have two roots when t equals to 0 and t equals to 4. So, we can put in our smiley face into our s's, so we get this. Alright, and just now, we have found that when t equals to 2, the maximum or the minimum displacement is actually negative 4. So look for the displacement when t equals to 6. Alright, so we will get displacement equals to 12. So this is the complete graph of the displacement time graph of the toy car. Question number 4. An experiment is conducted to study the motion of a particle along a straight line with the velocity v meter per second, t seconds from an initial point O. At t seconds after passing through point O, the velocity v meter per second is given by v equals to 3t squared minus 8t plus 4. At the beginning of the experiment, the particle is 2 meters to the right of O. So at the beginning of the experiment, the particle is 2 meters right of O. So gather all the information. We have v equals to 3t squared minus 8t plus 4. When t equals to 0, the s will be equals to 2 because it is 2 meters to the right of O. So we know we have positive 2 for displacement. So A, calculate the distance in meter of the particle from O when t equals to 5. So we need to find the displacement of the particle. So get the function of displacement by integrating the function of velocity. We get s equals to t cubed minus 4t squared plus 4t plus c. When t equals to 0, our s equals to 2, therefore 0, 0, 0, 2, so c equals to 2. Therefore, we have a function of displacement s equals to t cubed minus 4t squared plus 4t plus 2. And when t equals to 5, the displacement is 5 cubed minus 4 times of 5 squared plus 4 times 5 plus 2. There we get 47 meters. B, minimum velocity of the particle. So when we say minimum velocity, then our dv dt will be equals to 0. So when dv dt equals to 0 means that our acceleration equals to 0. So get the function of acceleration by differentiating the v. So we get a equals to 6t minus 8. So a equals to 0 means that the 6t minus 8 equals to 0, and we will get t equals to 4 over 3. So the minimum velocity happens when t equals to 4 over 3. So what is the velocity? Alright, so try to get t equals to 4 over 3 into the function of velocity, and we'll get minimum velocity equals to 3 times of 4 over 3 squared minus 8 times of 4 over 3 plus 4, and we get minimum velocity is negative 4 over 3 meter per second. C, the range of times in seconds when the velocity of the particle is negative. So when the velocity of the particle is negative, so v less than 0, so 3t squared minus 8t plus 4 less than 0. By factorization, we get 3t minus 2 times t minus 2 less than 0. And by sketching the graph of 3t squared minus 8t plus 4 with respect to the t-axis, alright, and our root is 2 over 3 and 2. The negative part, the function less than 0, will be in the middle. So therefore, the t is between 2 over 3 seconds to 2 seconds. D, the maximum displacement in meter of the particle from the O for t from 0 to 2. So when we say maximum displacement, the ds dt will be equals to 0, which means the velocity equals to 0. So we will get velocity equals to 0 happens when t equals to 2 over 3 and t equals to 2. So we have two values of t here. We need to find out which is maximum and which is minimum. So check on the second derivative of displacement. So we get second derivative of displacement, we'll get 6t minus 8. By sub in t equals to 2 over 3, the second derivative of displacement will be negative 4. So negative 4 value means that the displacement is actually maximum. Then check again when t equals to 2, the second derivative will be positive 4, this will be the minimum displacement. So the maximum displacement happen when t equals to 2 over 3. So sub in t equals to 2 over 3 into our displacement function. We get maximum displacement equals to 2 over 3 cubed minus 4 times of 2 over 3 squared plus 4 times of 2 over 3 plus 2. And we get 86 over 27 meter. Thank you.